The power of dreams.
More than 4,700 pedestrians are killed and 76,000 injured in the United States annually. These numbers could be reduced by using DSRC technology in vehicles and on smartphones carried by pedestrians. DSRC can help drivers be aware of hidden pedestrians. In this scenario, a pedestrian is crossing a street at a blind intersection. The driver is not able to see the pedestrian because he is behind a large vehicle. Also, the pedestrian is unaware that the vehicle is approaching. The pedestrian is on the phone or texting and is distracted. This distraction information is embedded in the pedestrian message. Thus, the vehicle becomes aware of the distracted pedestrian and warns the driver accordingly.
Pedestrian coming from the right.
At the same time, the smartphone interrupts and warns the pedestrian of the potential collision. The vehicle automatically applies the brakes if the driver does not react in time to avoid the collision. The collision is averted. Pedestrian can safely cross the road and thank the vehicle for stopping. Over 700 bicyclists are killed and 50,000 injured annually in the United States. Imagine a world where these numbers can be reduced or even eliminated. It can happen if both the driver and bicyclists are aware of potential collisions. A technology already exists that can help achieve this goal in the future. It is called DSRC, and it is wireless messaging for raising awareness of the road participants. Smartphones can be used as a transceiver and a warning device with the bicycle. Unaware of the approaching bicycle behind the building, the driver intends to turn left. Even though the bicycle is physically out of view, the system informs the driver of its presence.
Bicycle coming from the left.
If they are on a collision course, the vehicle will warn the driver of the approaching bicycle. At the same time, the smartphone will warn the rider that there is an approaching vehicle. This collision has been avoided. Both vehicle and cyclist can continue safely on their journeys. Unfortunately, there are 5,000 fatalities and 93,000 injuries involving motorcycles on the roads annually in the United States. A new technology is being studied that could reduce the number and severity of these collisions. DSRC can warn a vehicle and its driver of an approaching motorcycle before a potential collision happens. For example, a motorcycle is approaching an intersection behind a large van. The driver of the vehicle cannot see the motorcycle, but the vehicle receives a message from the motorcycle and can predict a potential collision and gradually warn the driver.
Motorcycle coming from the right.
At the same time, the motorcycle warns the rider of the potential collision. If the driver does not react to the initial informed display, a more aggressive warning is presented. In this case, a flashing brake is displayed, giving the driver sufficient time to react. Thankfully, the vehicle stops and the collision is avoided. Cellular and DSRC connectivity combine to help drivers detect and avoid road hazards.
Hazard ahead.
Drivers leverage the cellular network to automatically upload images of hazards, while DSRC connectivity provides the low-latency communication required for safety-critical detection and hazard avoidance. By providing the driver with an alternate lane, the driver can instruct the vehicle to navigate to the alternate lane and safely avoid the hazard. This demonstrates the possible safety benefits when combining these two communication channels, and it shows the potential of how we can eliminate conflicts before they even occur. Unfortunately, there are many tragic auto accidents still happening caused by sudden health issues, such as a heart attack. DSRC technology has the potential to reduce these accidents. If a driver is feeling ill, by simply pushing the emergency button, the vehicle transmits an SOS message via cellular network and also broadcasts a DSRC message to the surrounding area. The SOS button also triggers the vehicle to take control and automatically slow down along with engaging hazard lights. making surrounding traffic aware of the urgent situation. Surrounding vehicle or vehicles equipped with DSRC will receive an SOS request from the vehicle in need of assistance. A driver who volunteers to help will pull around the vehicle in need of assistance, and by simply pressing the Follow Me button, activates the auto following mode.
Following mode active.
Auto following mode will allow the vehicle in distress to automatically follow the leading car, in essence, towing the vehicle while not disturbing the driver that is in need of emergency assistance. The distressed vehicle automatically starts following the leading vehicle. No extra action is needed for the driver. Finally, both vehicles will meet an emergency vehicle in a secure location to get the driver in need of assistance the medical attention they require. A simple thank you message is able to be sent to the assisting driver as an appreciation for their kindness. Aiming to avoid dangerous situations brought about by driver fatigue and stress during long-distance highway driving, the automated driving system provides safe route guidance, driving support, and shared driving duties. The system calculates drive route from freeway entrance to exit, merges and exits at intersections, and maintains speed and lane while driving. The automated driving system employs several sensor cameras, so when traveling out of GPS range, such as in a tunnel, the car is able to remain in auto mode. Our vehicle is able to assess the surroundings and safely merge onto the freeway. When GPS is engaged, precise location measuring improves performance of automated driving. Since driving speed is limited to posted legal speed limits, it is unlikely passing would be implemented. At a freeway exit scenario, the system controls the vehicle and enables merging at the appropriate speed with automated steering, braking, and acceleration. Sensors allow the vehicle to keep safe distances from surrounding vehicles, road hazards, and road edges. The turn signal is also automated. During a continuous merge onto a freeway, not only is steering automated, but a unified system of steering, acceleration, and braking allows for smooth vehicle operation. Routes that require numerous lane changes and exits are also possible with the automated driving system. In this scenario, the number of lanes are changing and surrounding traffic is merging to an exit on the right. It is important to set the optimal lane destination beforehand to avoid unnecessary lane changes.